What is happening, grade 11s? Today we're going to look at John. Now, John is pushing a wheelbarrow filled with sand on a building site. The total mass of the wheelbarrow and its content is 30 kilograms. When he applies a force of 20 newtons, the wheelbarrow moves forward at a constant speed. Now, that constant speed is very important within Newton's laws, because if something is moving at a constant velocity, what does that tell us about the acceleration? Obviously, if the object's moving at a constant velocity, that means that our acceleration is equal to 0 meters per second squared. Now, that'll come in when we look at the equations. So our first question, what is the magnitude of the friction between the wheels and the ground? Now, we know that this thing is obviously on the ground, and we know that he's pushing it forward with 20 newtons. If we take Newton 2, force is equal to mass acceleration. We now don't know what that frictional force is, but we can find it out using our net forces. So that is our F net. Now, if we separate our F net out, that means that we'll have our force applied plus that frictional force will lead us to a situation where our acceleration is equal to 0. So let's look at this. We know that that frictional force should be a negative, and so if we get that out at the end, we'll know that we've done something correct. So 20 newtons is the force being applied, plus our frictional force is equal to our mass of 30 kilograms times the acceleration. Now, because it was at a constant velocity, we know acceleration needs to be 0. Therefore, it's 30 times 0. All right, so let's do some maths. That's obviously going to be 0, 20 plus our frictional force, and that means that our frictional force is equal to negative 20 newtons. And as I said initially, that we know a frictional force must be equal to negative because it's acting backwards. So we can now say that our frictional force is equal to 20 newtons. And this is for question A. Then the foreman shouts at John to hurry up. So we're telling John here to hurry up. And he increases his pushing force to 50 newtons. Firstly, we need to draw a labeled free body diagram. So let's do that. This is for question B now. So our free body diagram, we've got our wheelbarrow. We know that he is pushing forward with a force of 50 newtons now, and the frictional force is still that 20 newtons that we had originally, or that we calculated over here. And so that's going to be 20 newtons. The question then asks that it should be labeled, so this should then say force applied is equal to 50 newtons, force due to friction is equal to 20 newtons. Then question C, calculate the wheelbarrow's acceleration. So we're going to do a similar thing to what we did over here, but now we're going to use the new values that we've calculated. So F net is equal to mass acceleration. Our F net can be broken down into our force applied plus our frictional force is equal to mass acceleration. So the force applied we knew was 50 newtons plus our frictional force. Now we can see that our frictional force is going backwards and the force applied is going forwards, and so that will then be minus 20 newtons is equal to our mass of 30 kilograms times acceleration, and that means we get 30 is equal to 30a, which tells us that our acceleration is 1 meter per second squared.